Welcome to KNX tutorial number 15. Hello everyone, and in this video I'm gonna cover the Zennio Logic module. Uh, Zennio don't have their logic module, but what they do have, each device you buy, most of the devices of the Zennio have their built-in logic module. So every Zennio switch actuator, every dimming actuator, every heating actuator will have this function available. So in today tutorial I'm going to cover heating box 230 volt 8 channel. So it's going to be a heating box. What it does is it's mainly used for heating manifolds, so you can open and close head on it on using this actuator. Um, and it will have a logic function in it. So we're gonna cover this logic. We're gonna create this logic in the heating box. So if we look at the logic, so in this logic, what I'm gonna cover is underfloor heating logic. What it is, in this example, I have two different manifolds, and then I had got a towel rail, and hot water demand, which is most of the house they will have those. So if they have underfloor heating, so they will have like manifolds, then they will have a separate pump slash zone wall for the towel rail, and for the hot water, the same thing like that. So if you look at this logic, so what we got is on a manifold one pump, there is three bedroom which is feeding from manifold one, which is bedroom 1, 2, and 3. And for the next manifold, which is manifold 2, we got 6 room, 4, 5, 6, 7, 8, 9. I have picked 6 room on this manifold just to show you how to extend the logic on this heating box, Zennio Logic. So how to extend it, because once we are covering the logic, you will see it. You can do up to 5 and put it straightforward, but when it's become bigger than 5, then you have kind of a bit extra. You need to create a group address, and then if we see if manifold 1 pump is on or manifold 2 pump is on, then you need another OR gate which is turning on the main manifold pump. And if the main manifold pump is on, then, and if the towel rail and hot water, any of this is on, then you need to turn on the boiler and slash you'll have main circulation pump, which is like boiler. So you can, it's like the same logic, pull the same logic for the boiler and the main circulation pump as well. Okay, so let's go to the ETS programming. So what I'll do is, this is the actually module which I'm gonna show you. This is the ABB Zennio heating box, and you can download the ETS5 and ETS6 from here. I've got clouds enabled on my ETS, so I'm just gonna use the cloud of my ETS. Okay, so I will go to the catalog and I will find the heating box. Heating box. And this is the one which I'm actually looking for. So this is the heating box. I'll bring it here. So what I'm going to do is I'm going to create the group address when we are going on as along. So so I can explain it as well. I'll drag this to actually the cabinet here, and so if you go, you can enable the heating control here, but I'm not interested in the heating control. What I'll do, I'll show you one bit of this as well. So when I enable output one, what I will do is always enable those manual control. Yes, manual control lock. That is this. And what I'll do here is heating output one. I'll show the status object. So every time when I do if I look here, this status I will ask when I'm using uh, this channel in my logic, so I will connect actually this object here, not the top one, because that one, it might be linked to multiple group addresses, and you got a chance to miss it. But if you just link with this group address, this object, which will be status, then you're never gonna miss uh, any commands. So uh, that was just a side story. Let's go back to the generals, and we got a logic function here. I don't need to enable these bits. I'll just close. I don't want to I'll hide this. So logic function, and I'll just, you can't disable that. I'm gonna stay there. It's just because I have probably enabled this. So if I disable this, general, again, I can't, you can't disable this. So in the function, so let's me show you this first. So I'm gonna create this one, bedroom 1, bedroom 2, and bedroom 3, and then RGet. Yep. So let's go to the ETS. So what I got is 3 inputs, which is 1 bit input, 3 of them, and I will enable function number 1. I'll call this. This is very important. The trigger is very important. So I got 3 inputs. So input 1 should be trigger select, input 2 should be select, and input 3 should be select. What this means is each trigger, what it means is if input 1 have any change, like if it's changed from 0 to 1, then the whole function, this operation will get executed. If input 2 is changed from 1 to 0 or 0 to 1, then again this whole function will get executed, and the same thing for input 3. But if in case I somehow forget this input 3, not enable, and then I create a function which would be man 1 manifold 01 pump. Yeah. And I enable operation 1, operation 2, and this is if I use the input 1 R gate with the input 2, and then it's going out, the result is in B1, and then what I need to do to use it as a 3 channel together, then I'll use this as a 3 R gate, and this will be as I can just go down, you can see B1 down here and B1. So this logic will get executed, then this one and this will go to B2, and now what's going to happen, I'll create a function, a full OR gate, input 1, input 2, input 3, and this is OR, so it's the OR gate, so 3 input OR gate, I've created it. Now if you look here, I didn't enable trigger number 3. Now if you go look to operation, now channel 3, let's suppose this was 1, this was 0, this was 0, and this was 0, and the result was 0. Now suddenly this one, channel number 3, which is bedroom 3 status, come on, which was off initially, and then now it's come on, this operation not gonna get executed because there is the trigger, like key is not triggered. So it will only get executed when one or two is changed. So the state change. So you got to be make sure that every input is um, enabled here. Now this one is, and we got B1. The result should by default is B1 always, and then now we got result B1. And what I will do is we don't need send condition, but sending mode always result, and I will use this as a periodical sending because if someone override it, then you can just like probably after 10 minutes or something. So if someone come to the manifold and they close that zone, then you got a next command. It will automatically get settled down after 10 minutes because it will send another one and R0 and then it will go off. Now this is what we achieve is, if you look in the group object here, I got 3 inputs and the result is there. I'll have to create group addresses now. So I'll just create Zennio Logic, and here I'll create. Actually, I'm doing heating logic, so I'll just name it as a heating logic. Underfloor heating. Underfloor heating, and then if I press OK, and then in there I got a bedroom 1 status. I'm gonna just write down status because it's got to be status. Bedroom 1, bedroom 1 status, and then bedroom 2 status and 3 status. And bedroom 3 status. And then I will have manifold 01 pump. So this is, we'll link this to status 1 here, and then status 2 here, and then status 3 here, and this result will be coming on. You have to link, obviously you will have the heating actuator, all the wiring, everything, but in this video I am just trying to explain how the logic function work on the Zennio devices. So I've created one logic, and if we go back to the slide, so what we done, I've done this portion of the till the manifold 1 pump. I've done this. Now the next section is bedroom 4, 5, 6, 7, and 8, and then I got the manifold 2 pump. So let's go back to ETS again, and here first thing I need another 6 inputs. So if I go to the function, not the function first, I need to go to configuration, and then you get logic function input. It should be, it's down there. I'll close this. So input, total number of input. Now I need another 6 input, 3 and 6, 3 first bedroom and 6, so it will become 9. So I got, and I will need, in this case I will need enable 2 function because I'll show you why too. This is, so I will use number 4, number 5, number 6, number 7, and number 8. If we go in the operation, so we get 4 operation, which I can use it for 4 and OR gate, and then number 5. And the result, we got to make sure that it's not this like B1. We haven't used it in any other function, so I will have to use it as a B3, because if you look here, this one was finished on B2. So the next one you can have in this function, you can just use it B4 or B5, but you can't use B1 or B2, the result are B3, B1 or B2. So I've used B3. Now I can use number 6 here, input 6, and then OR gate with the B3. And then if I go on next one, I can again use there can't be, this one should be B3 and the result would be B4. So now what I'm doing is the result of this one, which is 6 and 5 OR gate, 4 and 5 OR gate, result going to B3, then 6 and B3 OR gate, result going into B4, and then 7 OR gate, and result 7 and B4. Actually, it's B4 is as an input, like to this operation, it's an input B4. So B7, data entry 7 and B4, the result is going into B5. As you can't use it, it's got to be a separate 1-bit object where you can store the value. So this is, and now B8. So B8 and OR gate for and B5 as an input to this gate. So the output on operation 3 should become input of the operation 4, and this is operation B6. And the result will be this number, the last one is B6, and that should be the result, B6. And whether you want to send it cyclic, sending mode cyclically, I think so, yeah, periodically, just let's do this one as well, 10 minutes. Now, here we have done 4, 5, 6, 7, 8. So it is actually 1, 2, 3, 4, 5. So 5 inputs. And that manifold, we got 6 input, which we need is, we'll have to do it, we'll have to come with a different way. That different way, I'll show you what that different way would be. So I will say manifold 02 pump part A, part 1 or part A, like part A, whatever you call it. And that is, and then in this function, so what we want is the output of this should go somewhere. So let's go to the group addresses. So what I'm going to do is, so the output of the first operation, which is this, Result number 2 will become input to the function number 3. So the result of function number 2 should become input the so this one will be goes and it will become input of the operation 3. So we'll need another 1-bit input. So what I'll need is, if you go there, so rather than 9, I'll need 10 of these inputs. Yep. And now what I have is, I'll have trigger number 9 and 10, because I'll show you what actually I've done. And then operation is manifold 02 pump part B. And in here operation, what I will do, or get, it is 9 or 10, and this is, I think so, let me see, that was, I think so, probably 6. Let's have a look what this one is. B6, so this can't be B6, that one should be B7, because B6 is used once and otherwise it's going to cause problem. And this one is sending periodically. No, we got result is different from the last one, always sending always. Might need to, I think so, this is, we'll need to see, I think so, this, we should just select this one always. And some devices, they give an option of sending periodically plus on a change as well, which is not happening here, but I just leave it as a 10-minute. This will need to somehow, this will need to be considered when you are commissioning this. We'll have a look whenever you are when you are ever doing commissioning, you got to do an office test or a bench test to see what's actually happening. I think it should send it on the sending as well on a change plus periodically. So now if we go to group addresses, so what I'll do is just copy this and paste it. So got a 7 and 2. First I got 5 input and then 2 more inputs. So what I'll do, this one I'll change it to, this is bedroom 4 status, and this is bedroom 5 status, bedroom 6 status, bedroom 7 status, and this is our logic manifold 02 pump logic extension. So actually I'm just extending logic through this object, group object, and then it is, this one is 8, and this one is, I think so, 9. What I need, no, this one should be, what I'll do is, it should be on the top of that. Doesn't matter as long as you connect it to a right one. And this one, so this is number 8. So what I'll do now, I have to link these. So this one is input 4, input 5, input 6, input 7, input 8. So the result of function 2 will go in here. So manifold 2 pump logic extension, and this one number 9 will be input. So this logic extension will go to another function because I was not able to accommodate six input at the same OR logic OR gate. So I had to extend it, send it to another group address, and then use a channel input OR gate to accommodate that. And then I will have manifold 2 pump output, and then I got this one will be manifold 2 pump, and this is the result for the manifold 2 pump. Yeah, so this is we create the program for 2 manifolds. Now we got another 2 inputs, which would be hot water and tower rail. So what will okay, let's leave some blank spaces in here. So I'll add some group addresses. Let's add some more group addresses here. A few blank spaces. So I'll do like, and then after that I got look at this here. So then now we have another input which is for the tower rail, and the one is for the hot water demand. Yeah. So if any of these two is on, and now what we need is we need to create something for his the manifold UFH pump. So we need to create something for UFH pump, which means if any of these two is on, we need a manifold pump to turn on the manifold pump. So let's go back to the ETS. What we got here is manifold pump trigger. So if I change this to UFH pump, so I'm just gonna have this one as UFH pump, and for the UFH man pump. So this pump, a manifold pump, 2 pump or manifold 1 pump is trigger. If any of this is on, then I want to turn on this pump. So for that, I will need to add 2 more inputs. So if I go in here, logic function, I need to add 2 more inputs. So this is 10 plus 2 more, which is 12. And then I had another function, which would be, if I enable a function number 4, I go down here, I can just use triggers, which would be number 11. I'll just move this there so we can see it much better. Number 11 and 12, trigger number 11 and 12, and then operation I call it UFH pump man pump. This is just so I understand my logic myself. You don't even, like, if you don't write anything here, it's not going to make any difference. So this is number 11, and then OR gate, and then number 12. But make sure this should be different. This one is, what was the last one we finished here? Oh, that's wrong. So we have done mistake here. You see, it's B1. This shouldn't be B1. This should be B7 here. So this is B7. output 7. Then we can use now B8. So this will be B8. Those are B number is actually, you can just store 1-bit value on it. So it's like a storage. You can save 1-bit object in it. And the result should be B8 here. And sending mode is periodic, which is minutes, 10 minutes. I'll just 10 minutes. Okay, now what I'll do, I got two more input. So this one, manifold 1 pump, and this one, I just quickly drag and drop, because you can just, you can do it this way like this, because I know it's, these are the same group addresses, or you can just, if you go to a group address like this, you can quickly drag and drop, or you can do it like this as well, manifold 1 pump here. It's exactly the same thing. So I drag manifold 1 pump. If I want to drag, not the logic extension, manifold 2 pump from here, it's the same thing. Or if I want to just drag it, drop from here, manifold 2 pump from here to there, it's the same thing. But the output will be going into now. This one is going in UFH pump. Yeah. So now after this, so we done. So it will come now. We done the manifold and underfloor pump, the main pump. We have done all the logic for that. If you look, we see here. So we have done that logic. This section top, this section till here. This is being done, and the UFH pump is being done as well. So now, if the UFH pump is on, this one UFH pump, oral demand or hot water is on, any three of these, we need to turn on the boiler. So let's go again to ETS. What we need is three. Let's create group addresses. I need what I need. I need to create our rail status and hot water status. And then what we need is and the final is boiler on up. So we can just say boiler on / off. So for this, we got one input. This is one input, and this is one input. So we got three further input, which will, when they become, and any of these three is on, then we need to turn on the boiler. So if we go click here, again go to parameters, we need another, how many input do we need? We got 12 inputs already, so we need 3 more inputs, so this will become to 15. So we need 15 input. If you click here, we can have up to, if you look, you can see this 0 to 32, 32. You can have actually 32 different inputs, 1-bit inputs. So let's use this function number 5, and this is trigger. So this should be 13, 14, 15, 13, 14, and 15, and then operation, which is boiler on / off. And what we need is, we need number 13. Oh, sorry, this should be number 13. 13 OR gate, and then 14, and this was the last one was B8, so we can't use till B8, so this should be B9, and then again because we got 3 inputs, so number 15, yeah, number 15, and then OR gate, and then we got use B9 as an input to this function, this operation. So that is that B9? Yes, B9, and then it's going to become B10, and this result will be B10, and then sending is periodic, 10 minutes. So it's 10 minutes here, and now what we do is link these group addresses there. So input 1, which is UFH pump, which is what I'll do, just UFH main pump is input number 13, and then I got another 2 input, which is towel rail and hot water, and the output of this function number 5 will go to the boiler. Yeah, so what we done is we have created a logic which is if you understand this logic, you can do any sort of manifold underfloor heating logic. You can create really easily any kind of underfloor heating logic. This is not Zennio. This logic functions are not really user friendly. They are little complex, not little complex. They are quite complex. You have to be really careful to don't do any mistakes, and you got to make sure that once you've done it, you gotta test each and every input, try them whether it's in office or on the side, and go through them. You will always find that you have done some mistake. Once you get used to it, then you will not do that mistakes at all. But yeah, so you got to be very careful because this B1, B2, B3, sometimes you can get lost in it really easily. So you got to make sure that you have done that correctly. And if we go back to logic, so we have create the boiler demand and everything. That logic is all done. So I think so. You should not have any problem using the Zennio Logic module. The good thing about this is if you buy any Zennio device, heating actuator, switch actuator, dimming actuator, or anything, you don't need to buy a separate logic module because these devices all come with the logic module. Cost effective, really good cost effective because you're just kind of avoiding to buy another device. So that's why they're really good. So thank you for watching my videos, and if you are following them, thank you so much. Please do leave your feedback and press like button if you like the video, and do subscribe as well so you can so you don't miss the other useful video which I'm gonna make in future. Thanks for watching.